This is similar to the question we had in question 1 because it is. It's a coil. When you put it in between two magnets, it can either act as a motor or a generator. If you put electricity into it like this one, it's a motor. If you do the winding yourself, wind it around with your hand, it gives electricity out, it's a generator. So this one's about, it is a motor, there's electricity in. So here's a square loop, VW, and the north and the south are for the magnets. So we know there's field lines going from north to south. I'll just draw them over here out of the way. We've got a magnetic field here. They've given us the side of well, they're all the same size, but that's the size. And we've got the current, we call it I, 2 amps. Alright, indicate with an arrow the direction of the force on the side TU. So this is the right hand slap. We know the field lines are going that way. We need to know which way the current's going. The current comes out of the positive. The big one's the positive, the little one's the negative, and into the negative. So it comes out and it goes along there, and it comes back this way. So if I was to use my right hand slap rule for this, the way I'd be positioning my hand is in the following way. My fingers are pointing that way because it's the field, and my thumb is pointing in the direction of the current. That's the field line, and this is the palm of my hand, so my fingernails are facing down, my palm's facing upwards. I get a force upwards. I'm going to draw it in green so you can clearly see where my arrow is, an upwards force on that. So that's that one done. Alright, calculate the magnitude of the force on the side TU. Show you working. Okay, for the size of the force here, we have to use F equals N bil. It's a single loop, so N equals 1. And then we've just got to put all our values in here. So 1 times magnetic field is 0.25. I think the current was 2 amps and the length was, I think it was 0.09. 0.009. So when you do that, you get it's a half times 0.009. And half times 0.009 must be 0.0045 newtons. Alright, what's the magnitude of the force on the side UV? So UV is this guy along here. Now that's running parallel in the same direction as the field lines. And because of that, there's no force. So it's worth 2 marks. We have to say 0 newtons, because UV is parallel to field lines. Alright, and last question here. Explain the purpose of the split ring commutator. This question comes up every year, so you should have something like this on your cheat sheet. Without the split ring commutator, side TU will always receive an upwards force. If it's always an upwards force, there's a force here, and when this side is TU, flips over. So this is now TU, and it has another upwards force. It's just going to flip back again. So it's going to go this way, it's going to turn it this way. When it gets to that side, it's just going to turn it back again. So they will always receive an upwards force leading to oscillation. Instead of continuous rotation. And what does the commutator do? A commutator reverses the direction of the current in the loop. Every half cycle. And this produces forces, the correctly orientated forces. That lead to continuous rotation.